right, we're going to take a look at another example of using the quadratic formula to help us solve a quadratic equation. We are going to look at this in terms of finding what our x values would be when our y is 0. Those are your x-intercepts, your roots, your zeros, or your solutions. They're all called those things interchangeably. We're going to focus on x-intercepts primarily because I'm thinking about this in terms of graphing. So I'm going to start here. You'll see my equations written, my formula is written on the left. I'm going to identify my a, which is 8, my b, which is -4, and my c value, which is -18. Those are the values that I'm going to substitute in for my formula over here. So we're going to say x equals -4 plus or minus the square root of -4 squared minus 4 times 8 times -18 divided by 2 times 8. And again, that first step, it always looks like daunting because you have this huge problem, but we're going to simplify it here. So this is going to become a +4 plus or minus the square root of 16 plus 576. So if let me fix that radical there so it's not quite so big. If I multiply -4 times +8 times -18, I get 576. And all of that divided by 16. So x is going to equal 4 plus or minus the square root. That's going to give me 592 divided by 16. Now, the square root of 590 is supposed to be 592. Let me fix that. There we go. The square root of 592 comes out to be a decimal. If I want to make this an exact answer, I can simplify that radical because 16 times 37 is 592, and 16 is a perfect square. So since this would be 4 plus or minus the square root of 16 times 37 divided by 16, I can pull this 16 out because it's a perfect square, and it would be 4 plus or minus 4 times the square root of 37 divided by 16. Then I can simplify this one step further because I've got 4 and 16 here, and I can divide all of those things by 4. So I would have 1 plus or minus the square root of 37 divided by 4. And that's going to be the two values that this is what I'm going to use to find my actual x-intercepts. So I would have 1 plus the square root of 37 divided by 4, and I would have 1 minus the square root of 37 divided by 4. Now, if I were to plug that into my calculator to get something to graph, because it's difficult to graph a radical when you don't know the exact value, I can round it 2 decimal places, and the first one's going to give me 1.77. The second one is -1.27. So my two x-intercepts are going to be 1.770 and -1.270. And I'm writing them as ordered pairs because, again, I'm thinking about this in terms of graphing. So let's talk about our vertex now. In our previous video, we talked about how we can find the x value of the vertex by taking -b divided by 2a. So in our problem, that's going to be -4 divided by 2 times 8, which is 4 divided by 16, which is 1/4 or 0.25. So once I have the x value, because my vertex, let's see, I'm going to write that down here, vertex, we know it's going to be 0.25 comma something. So we're going to go back to our original equation, and we're just going to substitute in what the x value is. So we have 8 times 0.25 squared minus 4 times 0.25 minus 18. Well, let's see, if I take 0.25 squared times 8, that's going to give me 1/2 or 0.5. This is going to be -1 minus 18, and that's going to give me -18.5. So there is my vertex. So again, I used the quadratic formula to find my roots or my zeros or my solutions, and I wrote them as x-intercepts. Then I used the formula to find the x value of the vertex and plugged it back in to get the y value to get my vertex, and now I would be ready to graph. Hope this has been helpful.